to jump down to number 11 and do one more with completing the square. Because I thought that this one looked like maybe the hardest of these three. So, remember when we're completing the square, we want everything with a variable on the left, constant to stay on the right. So I'm going to subtract 16y and add 150x to both sides. So that will give me 25x squared, add the 150x over, plus 4y squared, subtract the 16y over, and leave the 159. Any questions so far? Okay, so we've already grouped the x's and we've grouped the y's together because I went ahead and wrote them next to each other. So in this next step is where I factor out that greatest common factor, which is really just going to be that lead coefficient within each set of parentheses. So the 25 comes out front here, x squared plus, what's 150 divided by 25? You have $1.50. How many quarters are in it? 6. Do you ever think of it that way?
No.
I tell you what, when I'm dividing by 25, I always think of quarters. Okay, next set of parentheses, I'm going to factor out a 4. Y squared minus 4y, leave your space, equals 159. Okay, now we do the little funky step where we take this coefficient, divide it by 2, and square. That gives me 9. Okay, so I'm going to add 9 inside the parentheses, but, yes?
Did you not factor out 4y?
You don't want to factor out the variable because remember we're setting up a perfect square trinomial that has 2 exact factors. So you don't want to mess with the variables. But that is a good question because the variable was a greatest common factor as well. So we didn't really change the left by 9. I really changed it by 25 times 9, which is 225. So I'm going to add 225 to the right to keep it all equal. And we do the same little funky step here. Negative 4 divided by 2 is negative 2, but when I square that, I get 4. So I'm going to add 4 inside the parentheses, but I didn't really add 4 to the left. I added 16 because of the 4 in front of those parentheses. So I'm going to add 16 to the right to keep it all equal. Okay, next step we're going to factor. 25 stays out front. What are the factors of x squared plus 6x plus 9? X plus 3. There'll be 2 of them. So I'm going to go ahead and write just x plus 3 squared. 4 is out front, but what are the factors of y squared minus 4y plus 4? Y minus 2. So again, it's whatever you squared back here that goes in your factor. I squared a 3 plus 3. I squared a negative 2 minus 2. And then we're going to add up the right-hand side. Oh my goodness, what does that give us? 400 even. Well, that's nice. Okay, everything gets divided by 400. And then we'll do the reducing. So 25 over 400 gives us what? 16. Let's see, I'm going to come over here and write the equation. X plus 3 squared over 16. And 4 over 400 reduces to 1 over 100. So I have y minus 2 squared over 100 equals 1. And that would be my equation. Everybody okay on that one? Okay, so remember these are accessible on your quiz. Okay, so the next thing that was at the bottom of that homework yesterday that we did not get to in class is eccentricity. That's kind of a fun word to say, isn't it? Eccentricity. It sounds fancy. So the eccentricity of an ellipse is the ratio, so think fraction, of C to A. So it's the fraction of C over A over here on the left. And what it describes is how circular or elongated the ellipse is. So remember how we watched the video, and if the foci get really close together, then the ellipse is really circular. But if the foci are really stretched out from each other, then it's a really flat, narrow ellipse. So that eccentricity describes that. The closer the eccentricity is to 1, the more circular it is. And the closer it is to 0, the flatter or more squished the ellipse is. Okay? All right, so all we need to know is what is C and what is A to figure out the eccentricity. Looking at number 12, what is A squared in this equation? What is A squared? 49. Okay, A is 7. So A squared is 49. A is 7. How do I know which one is A squared? It's the bigger one. Okay, so B squared is 36, which means B is 6. Now, I don't need B for eccentricity. I only need C and A, but I don't know what C is. Remember, that's your distance to the focus. So in order to find C, I do need A, because I'm going to use the formula C squared equals A squared minus B squared. Okay, so C squared equals A squared 49 minus B squared 36, which gives me 13. So what is C? Square root of 13. Okay, so now I can tell you that the eccentricity is C square root of 13 over A, which is 7. Now, is that close to 1 or close to 0? I don't know exactly. I'd probably need to get a decimal approximation, right? So let's see what the square root of 13 over 7 equals. Oh, it's the square root of 13 over 7. Of course. Let's get a decimal. Oh, so it's kind of right exactly in the middle of being circular or flat, because that's about 1/2 or 0.5. Okay, so it just gives you an idea without graphing of how rounded or flat it is. Yes, sir. Yes, absolutely. Okay, you guys try 14 for me. Okay, I'll work it out up here too, but I'm not going to talk through it. So find your C, find your A, and then write that ratio of eccentricity. And if you want to say eccentricity, that's okay too, because it's really a cool word to say. See, Maddie, it's fun, isn't it? Okay, so check up here. I got square root 21 over 5. Y'all agree? Any questions? And I think I said that backwards. I think I said closer to 1 is more circular. And it's the opposite. Closer to 0 is more circular. Closer to 1 is more elongated or flat. And I don't remember what I said now, but for some reason I think I said that backwards. This one, did anybody get a decimal? This one is like 0.9. So that means that this one is very squished, very narrow, compared to this one up here. So closer to 0, E closer to 0 is more circular, and E closer to 1 is flatter or elongated.
So what if it's in the middle?
Then it's just like a nice little rounded oval. Okay, so we'll picture this. So see how this is 36 and this is 49. So A is 7, but B is 6. So we're not going out very different amounts from the center. You can picture that that would be more circular. If I go up, down 7, left, right 6. That's kind of almost the same. Okay, but this one, I'm going left and right 5, up and down 2.
So it's like more like an oval.
Exactly. So those are, yeah, there's a bigger what's the word I want? I can't think of the word I want. Anyway, bigger difference between those two. So it's more oval-like rather than round, circular-like. Okay, so the closer these numbers are together, the more circular, the farther apart they are, the flatter or more narrow. Okay. All right, next page. What we're going to do next is take graphs of ellipses that are already graphed, and we're going to figure out what the equations are. So we're doing the exact opposite that we did on Friday. So look, you might want to grab your formula sheet. These are the formulas that we're going to be writing. And here is the equation for horizontal. Here's the equation for vertical. So there's not a whole lot of difference, is there? You just have to know if it's vertical or horizontal to know where to put a squared and b squared. Other than that, they look identical. Okay, so what 3 pieces of information do I need to know in order to write the equation? What would I need to know? I need to know the center. And what else did you say? A squared and b squared. So those are the 3 things that we need to know. Where is it centered? What's a squared? What's b squared? And if we can figure out those 3 things, then we can easily sub it all into the equation. Okay? All right, so easy enough. Where is this thing centered? Can you tell? And count in, from each side if you need to. Even if I figured out just looking at it, I think I would still sort of count out to each side and make sure I did get it in the middle. So I think that's the middle there. What is that ordered pair? -1, 2. Well, once you find the center, guess what? There's your H and your K. So we'll be able to sub those into the formula for the equation. All right, vertices. Vertices are those 2 of the 4 points that you connect that are farthest from the center. Okay, well, this one on the left is 1, 2, 3, 4, 5, 6, 7, -8, 2. And someone asked earlier, does it matter which one you list first? Absolutely not. 1, 2, 3, 4, 5, 6, 2 is the other one. Okay, the covertices are these that are closer in that you use to connect and draw the ellipse. So this is -1, 5 and -1, -1. Okay, the foci, I'm actually not even going to worry with that because all we're really going to do is come up with the equation here. So I'm going to skip that part. But how would I find it if I needed it? I would have to use c squared equals a squared minus b squared, find c, add it to the center point. Okay, so I know h and k. Do I know a squared and b squared? I can find them pretty easily, right? Remember, this is a, so that's 1, 2, 3, 4, 5, 6, 7. So a is 7. And then this distance here is b. So we'll just count 1, 2, 3. B is 3. Well, if I know a and b, I certainly can find a squared and b squared. So a squared will be 49, and b squared will be 9. Okay, so we know everything we need for the equation. This is horizontal. So for horizontal, I'm using this equation right here. So I need x minus h. Well, if h is negative, when I subtract the negative, it'll become plus 1 squared over a squared. A squared was 49. Plus y minus k, y minus 2 squared over b squared. B squared is 9 equals 1. Who has a question? All right, let's do number 2.
Can you go back on that?
Yep.
Whenever you don't have the graph like that, like when it's circled already, and you have to find the vertices and co-vertices yourself, how do you do that?
Like what we did on Friday? Okay, so if we just have the equation like these back here, to find the vertices, the first thing you're going to do is plot the center point, and then you figure out what a is by looking at your biggest denominator. So in this case, a was 8. So from the center, in x direction, left and right, we go 8. And then those ordered pairs were our vertices. Okay, b squared was 25, and it's under y. Square root of 25 is 5. Y goes up and down, so I go up 5, down 5. Those ordered pairs are the co-vertices. And then we have to find that c value by using c squared equals a squared minus b squared. And that's the distance to the focus. Since I'm going left and right, I will add that to the x coordinate. It changes the x coordinate, but not the y coordinate of the center. Were you here Friday? Okay, so go back and watch that video, and that should help. Let's go ahead. I know I said we're going to skip the foci, but let's go ahead and do the foci on this one. And then we'll skip it on the next two. Okay, so finding the distance to the focus. I get c squared equals a squared minus b squared. A squared is the biggest denominator. B squared is the smaller denominator. So that would be 40, and c would be the square root of 40. Now that does simplify. That's 4 times 10, so that becomes 2 square root of 10. I'm just going to be lazy and leave it square root of 40. Now, the focus is always in the longer direction. So I need to go left and right from the center to get to the focus. The square root of 40 is between what two numbers? 6 and 7. So I'm going to go right 1, 2, 3, 4, 5, 6, and a little bit more. And then same in the other direction. So the foci are somewhere in there. Now to write those ordered pairs, we started at the center point, which is -1, 2, and I went right and left from the center point. So I'm going to add and subtract the square root of 40 to the x coordinate, Jerry, and not the y coordinate. So that's going to be -1 plus or minus square root of 40, comma, 2. If I went up and down from the center point, that plus or minus 40 would be added to the y coordinate. But if I'm going left and right, it gets added to the x. Question, and for those of you who weren't here Friday, go back and watch that explanation on Friday's lesson. Okay, so number 2. This one is vertical. Clearly, right? No guessing, it's vertical. So here's the formula I'll be using. I need to figure out the same 3 things. The center point, a squared, and b squared. Okay, so we're going to eyeball where the center is. Right there. What's that ordered pair? 3, -2. Okay, so A is the longer direction out to a vertex. So 1, 2, 3, 4, 5 is A. B is the distance, that shorter distance from the center. So B is 2. Okay, well if A is 5, A squared is 25. And if B is 2, B squared is 4. So I know A squared, I know B squared, I know the center point. We can write the equation of the ellipse. And it's vertical, so remember we're using this one. So it's x minus h squared over b squared, which was 4, plus y minus k, but k is negative, so that becomes y plus 2 squared over a squared, which is 25, equals 1. Okay, and for the vertices and covertices, all we're going to do is name those order pairs. Oh yeah, I didn't write it in, did I? I just said H. Thank you. Let's actually fill that in and make it a 3. There we go. Thank you. Okay, so vertices and covertices, we can name those order pairs, right? We're good with that. Okay. All right, you want to try number 3 on your own? Okay, try number 3. I'm going to work it out up here as well if you need to peek. Find the center, find a squared, find b squared, write your equation. So someone asked, is it okay if you have x minus 0 squared? Absolutely. Some people prefer to write it that way, just as a reminder that that x coordinate is 0. So if you have x minus 0 squared, perfectly fine. Okay, does anybody have any questions on that one? Yes, ma'am.
Okay, so I put the x minus 5 over the 64.
I did that too on first time.
Okay, so remember, do you have this center point?
Yes. No, I'm 0, 5. Wait, 5, 0.
I did that at first too. That's weird. And yeah, it's 0, 5, so that's why yours is backwards, because your center's backwards. Okay, any other questions?
I have 64 over
64 over x squared?
No, x squared over
1.
I have x minus 0 squared over 1.
Okay, so go back to this. So your A is the longer distance across the ellipse. So A should be 8 and B will be 1. And when it's a horizontal, A squared goes under the x term. Okay, any other questions? Okay, so you feel okay with that? All right, so last, we're going to do 5 of these on the last 2 pages. We're not doing them all. We're going to just be given certain information about it, not a graph, but certain information, and we're going to come up with the equation. Okay, so remember, to find the equation, we need the center, we need HK, we need to know what A squared is, and we need to know what B squared is. And that's all. We don't need to find C, although we might sometimes need to use C to find A or B. Okay, so it helps me if I sketch a little picture, even if it's not to scale, just to sort of see, is this horizontal, vertical, where's the center located, etc. So if these are my vertices, at 5, -2, and -19, -2. Okay, now that is not to scale. It just gives me a visual. Okay, that's where the vertices are. Therefore, is this horizontal or vertical? Horizontal. Okay, so it's a horizontal ellipse. So when I go to write the equation, I'll choose that one that goes with horizontal here. How is this going to help me find the center?
How do we know what's on?
Because those two, remember the vertices are the ones in the longest direction. And these are lined up horizontally with each other. If it was vertical, then the 2 vertices would be lined up like that.
Yeah, but how do you know?
Because it told me that those are the 2 vertices instead of the co-vertices. The co-vertices will be the short distance. Okay, any other questions?
Why are you not looking at the other part of like the
This part?
Like, why are you looking at the 2?
It's -2, so that's why I dropped down 2 when I plotted them. But that's not what you asked?
No, it is. I just.
Okay.
I don't know. It's not making sense to me. Maybe it's because it's not the whole graph, but like.
Yeah, it's not. So it's like just giving you enough pieces about the ellipse so that you can figure out what the equation is. So visually, place those just so you can tell if it's horizontal or vertical. They will either be lined up across from each other or above each other. Okay? So, what do I find halfway between these 2 points? The center. Okay, so walk it in from the end or average those 2 numbers to figure out what's in the middle. So -19 plus 5 is -14. Divide that by 2, that's -7. So that tells me at -7, -2, I will find the center. So you may have a question about that. Do I need to back up and re-explain anything about the center? Mm-hmm.
How did you know that it was -2 with the -7?
Because it's got to be lined up with these. So it's going to have that same y coordinate. Anything else? Okay, so there's the h and the k that I needed. I need the center for the h and the k. Do I know a squared or b squared, or can I find them somehow? Yeah, if I know the center and a vertex, isn't A just the distance to that? So how far is it from the center to that point or the center to that point? 12? Yes? So A squared is 144. So I'm just looking at distance. How far from -7 to +5? That's a distance of 12. Okay, so now how do I find B, or B squared? Let's look at this other piece of information. The length of the minor axis is 10. Okay, go back to the front page. Major axis is distance from vertex to vertex, kind of like the width of the ellipse. Minor axis is the distance across the shorter part of the ellipse, and it will help me find B. Remember, the length of the minor axis is 2b. Length of major axis is a plus a, or 2a. Okay, so if my minor axis is 10, that means that 2b is 10, and b is 5. And b squared is 25. Okay, the minor axis is the shorter, kind of like diameter of the ellipse. So if I know the whole minor axis is 2b, then I just take half of that to figure out what b is. Okay, so my minor axis length is 10. So 2b is 10, which means b is 5, but I need b squared in the equation, so 5 squared is 25. Okay, so once you find those three things, center, a squared, b squared, then you can put them all into your formula. Okay, so this is a horizontal equation. Here's my formula. X minus -7 is plus 7 squared over a squared. A squared was 144. Plus y minus k. K is also negative, so that becomes plus 2 squared over b squared, which is 25, equals what? I think these are a little bit harder just because they're a little more abstract. If it helps you, get a piece of graph paper. I have some over there, and actually plot it on graph paper if it helps. Okay, let's look at 6. All right, so this one gives us vertices and covertices. All right, so if I just do a little rough sketch here. 12, -6, and I've got to go down to -9. These are not to scale. Those are the vertices. And then the covertices will be 3, -7, and 3, -11. Okay, so I have vertices left and right, covertices up and down. Okay, well, where's the center? It's going to be in between these or in between these. Halfway between either one of those. I'm going to take these right here. What's halfway between 12 and -6? Average those two numbers. What do you get? But divide by 2, 3. Okay, so if you want to know what's halfway between two numbers, you're just averaging them. So 6 plus 12, I'm sorry, -6 plus 12 is 6. Divide by 2 is 3. So -6 plus 12 divided by 2 gives me 6 over 2, which is 3. So that tells me the center is 3, -9. Is this horizontal or vertical? Horizontal. Vertices are left and right.
Did
Yes.
you take the negative 6 and 12 because it's longer than...
Uh-huh. Yes. But now look, I could have averaged what's halfway between those and I would have found the center also. The 3 will stay. Negative 7 plus negative 11 is negative 18. Divided by 2, I get negative 9. So if you have vertices or co-vertices, the center's in the middle.
So you don't have to do all the graphing if you're given vertices or co.
You don't have to. It just helps me to have a picture to see if it's horizontal or vertical. Okay, any other questions so far on finding the center? Okay, so now we have to find A and B so that we know A squared and B squared. Well, that's pretty easy on this one because they gave us the vertices and co-vertices. So the distance from center to here is A. How far is it from 3, negative 9 to 12, negative 9? 9, right? Okay. How far is it from the center down to that little point? So I'm at 3, negative 9, and I'm going down to 3, negative 11. 2. So B is 2. Question? Charlie, question? Sure? Jerry, question? No? Okay. Your faces just look like you had a question. Okay, so I have A, I have B, therefore I can easily find A squared and B squared, and I know H and K. It is horizontal, so I'm using this one again. So it's X minus 3 squared over A squared. Well, if A was 9, A squared is 81. Plus Y minus K, but that's a negative 9, so plus 9 squared over B squared, which is 4, equals 1.
How did you find the B equals 2?
Because I knew where the center was, and these co-vertices here, I'm just asking myself how far to there or to there. Because B is the distance from center up to co-vertex. Okay? Yeah, I think graph paper helps. I'll graph the next one. How about that? I'll graph paper and you can see if that helps. And if you need some, there's some over there. Alright, let's do number 8. Okay, vertices are 5, 11, and 5, negative 15. Ooh. One, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and negative 15. Those are my vertices. You'll see, there we go. Okay, so is this vertical or horizontal? Vertical. Okay, so it's a vertical ellipse. Where's the center point? How do I find it? Average. Okay, so this was 5, 11. And this was 5, negative 15. Okay, well clearly the x-coordinate will be 5. So I'm going